Good morning to all of you. In previous sessions, we have seen properties of discrete Fourier transform, where we have seen periodicity property, linearity property. Then we have seen multiplication of two DFTs property, which corresponds to the circular convolution. We have also seen examples where we identified circular convolution directly, and another example in which we have identified the circular convolution by using multiplication of two DFTs properties. In last session, that is previous session, we have seen time reversal of a sequence and circular time shift of a sequence properties. Today we will discuss circular frequency shift and multiplication of two sequences property, right? So first we'll see the circular frequency shift property. So as per this circular frequency shift property, if there is discrete time sequence x of n with endpoint DFT as x of k, then the frequency shift in the frequency domain, okay, that is circular frequency shift in the frequency domain, that is x of k minus L. Okay, so frequency shifted by L samples here, right, with circular period of capital N. Then in time domain, this signal will get multiplied by e to the power j2 pi L n by capital N, right? So this is nothing but the circular frequency shift property. So the multiplication of a sequence x of n with complex exponential sequence e to the power j2 pi L n by capital N is equivalent to the circular shift of the DFT by L units in the frequency, small L units in the frequency. So this is as per the circular frequency shift property. The another property that we are discussing here is multiplication of two sequences. So before this property, we have seen multiplication of two DFTs, which corresponds to the circular convolution, right, in the time domain, right, when we are multiplying two DFTs in the frequency domain, right. So here we are multiplying two sequences in the time domain. That means if we have been provided with two sequences, if there are two discrete time sequences x1 of n, okay, and second is the x2 of n with their respective endpoint DFT indicated as or denoted as x1 of k and x2 of k respectively, then their multiplication of these two sequences in time domain, that is x1 of n and x2 of n, if we are multiplying these two sequences in time domain, then in frequency domain it will be simply the circular convolution of their respective discrete Fourier transform, that is x1 of k circularly convolved with, this is the circular convolution operator, right, circularly convolved with x2 of k. So their respective DFT circular convolution multiplied by 1 by n. Okay, this is nothing but the multiplication of two sequences property. So the when we are multiplying these two sequences in time domain, so in frequency domain it will be the circular convolution of their respective DFTs multiplied by 1 by n. Okay, so you can try the proof of these two properties, right? So in next session we will be discussing efficient computation of DFTs. Okay, that is by using fast Fourier transform, that is nothing but FFT. So thank you for joining this session.